For decades, we have treated creative inspiration like a mystical event, a sudden, unpredictable flash. But neuroscience reveals a more physical constraint. Human creativity is often limited by the rigidity of our established neural pathways. The shift in cognition happens because the molecule forces the brain to explore flexible, novel network topologies that are usually inaccessible. To understand how this disruption works, we have to look at the brain in its baseline state. Inside an fMRI scanner, when you aren't focused on a specific task, your brain operates through what is known as the default mode network. Anchored by the medial prefrontal cortex, posterior cingulate cortex, and angular gyrus, this network manages mental simulation. Normally, it falls into rigid states, a neural rut blocking novel solutions. Highly creative individuals avoid these ruts through flexible connectivity with the executive control network. From this perspective, a creative block is a measurable biological state, an indication that the default mode network has become too rigid. In 2012, researchers at Imperial College London used fMRI to document how psilocybin physically alters this rigid baseline activity. The data showed that activity in the major hubs of the default mode network dropped by 40%. This suppression breaks the network's rigid hierarchy, effectively vacating the neural rut. The 2014 entropic brain model explains what happens next. While a low-entropy network cycles through limited configurations, a high-entropy network rapidly samples hyperconnected, diverse states. Without a central hierarchy, the brain is forced into a state of high informational entropy, expanding its functional landscape. fMRI data from 2014 provides a quantitative look at this expansion. Under psilocybin, the brain samples 4 to 6 times more distinct dynamical states per unit of time compared to a placebo. In this state, the brain begins to map cross-domain connections and conceptual linkages that are typically filtered out. This temporary period of neural flexibility mathematically forces the brain to traverse conceptual space in unusual ways. This entropic flexibility appears to translate to measurable output even at sub-perceptual microdoses. Creativity requires 2 distinct cognitive faculties: divergent thinking, which generates a breadth of ideas, and convergent thinking, which identifies the single most effective solution. In 2018, researchers in the Netherlands tested these faculties in a naturalistic study of individuals who were microdosing. On dose days, participants scored significantly higher on the alternative uses task, a standard measure of divergent thinking. Participants also showed gains in convergent thinking and fluid intelligence, suggesting that expansive idea generation does not come at the expense of focused evaluation. While the study was not double-blind, it established that the functional cognitive output on dose days was measurably different from the participants' own baselines. The neural flexibility seen in macrodoses appears to scale down, acting as a real-time enhancer of problem-solving mechanics. High-dose sessions rarely produce immediate creative output. Instead, many users report a surge of new ideas in the following days. This delay is explained by the relationship between mind-wandering and creative incubation. A 2012 study demonstrated that unguided mind-wandering facilitates a 41% improvement in solving creative tasks participants were previously stuck on. The high-entropy psilocybin state functions as a radical form of mind-wandering, where associations meander and leak without usual hierarchical constraints. The session serves as an advanced incubation period, preparing the brain for insights that arrive 24 to 72 hours later. Biologically, this critical window is characterized by elevated neurotrophic growth factors, like BDNF, which drive rapid synaptic remodeling. The acute experience provides a biological environment for incubation, priming the brain for the insights that surface once the session concludes. While microdosing offers acute benefits, high-dose macrodoses can trigger a more lasting structural reorganization of the brain. In 2011, researchers at Johns Hopkins tested long-term personality changes following a single high-dose session. They tracked the trait openness to experience, which includes aesthetic sensitivity and imagination. Meta-analyses consistently show this is the strongest predictor of creative achievement. Participants showed an increase in openness exceeding 1 full standard deviation, a shift significantly larger than what is typically seen in adult personality over decades. This shift remained elevated at the 14-month follow-up, representing a level of persistence rarely documented following a single intervention. Data from the 2006 Griffith study showed that these trait increases correlate with how meaningful the participants rated their acute experience. Meaning-making is a cognitive process. A profound subjective experience often indicates a deep reorganization of the brain's representational structures. This suggests that the profound subjective experience reported by participants tracks with the long-term structural neuroplasticity measured in the weeks following the session. The pharmacological mechanism reorganizes the brain's architecture to be more receptive to novel information, creating the underlying conditions for creative insight. However, the science is clear. Expanded openness and entropy are not substitutes for craft, skill, or sustained effort. Pharmacology can vacate the neural rut, but it is entirely up to the individual to build a new path through the opened landscape.